Welcome to lecture number 56, case studies of object oriented programming. So, whatever we have studied till week 11, right? So, we will take some of the important applications, right? So, the important syntax, based on that we will develop some project, right? So, that we call it as case studies, right? So, the main objective of this chapter, right? So, we are going to apply all the object oriented concepts that we have studied in this particular course, right? So, we can apply those into the real world scenarios. So, for example, I am planning these case studies, right? In today's lecture, let us have the mathematical computational framework using C++, right? So, I am going to cover C++, 2 examples of C++, 2 examples of Java and 1 example with the help of Python. So, in today's lecture, we will discuss about the mathematical computational framework, right? Mathematical computation framework. So, that means we will perform certain operations like, let us say, solving equations, right? So, suppose you are given a system of equation like this Ax is equal to b, which is very much, all right, useful. Let us say problems like machine learning or neural network, you study like Wx is equal to b, solving Wx is equal to b, right? System of linear equations. Similarly, the matrix computations, finding out whether the inverse exists or finding out the eigenvalue of a square matrix, right? Or you have to find out whether the matrix is singular or not, right? So, these kind of operations, so I had given some examples, we will deal, right? And after this, we will see one more example on C++, the hotel reservation system, right, with the help of object oriented programming concept. The third one is online shopping cart, all right. So, we are going to create a shopping cart system with the product hierarchies, and fourth one is with the help of Java, right. So, the third one is with the help of Java, fourth one is also with the help of Java, employee payroll system. So, we will manage the payrolls, all right. So, increment, all right, or anything, or bonus, all right. So, these are all right, we will manage the payrolls. So, here what we will do, we will use the abstract classes and interfaces, and finally, we are going to wind up with image classification tool using Python, all right. So, most of you might have heard, right. So, we are in the AI ML world, right, and image processing is one of image processing, and computer vision is one of the major area, right, where you can apply machine learning. So, to apply machine learning, you should know the basics of Python. So, we had seen some Python code. So, now you try to apply for the image classification algorithms, right. So, the image categorization using pre-trained models, right. So, this will also be an interesting problem. So, we are planning to have 5 different projects or 5 different interesting problems, 2 with the help of C++, 2 with the help of Java, and 1 with the help of Python. So, now in this lecture we are going to see mathematical computation framework, right. So, the main objective is to build a modular framework for performing advanced mathematical computations. So, what do you mean by advanced mathematical computation? Let us say matrix operations, addition, multiplication, inversion, right, finding out the determinant of the matrix, right, or we can say how to find out the eigenvalue of the matrix, eigenvalues of the matrix, eigenvectors of the matrix. So, whatever applications that you know, right, so you can even add up, right. So, we are going to see certain basics, let us say addition, multiplication, inversion, etc. Similarly, we are going to solve the equations, solver, linear and quadratic equations, or important component, right, the statistical computations, right. So, under this we can have how to find out the mean if the data is given, right, set of vectors are given, how to find the variance, how to find the standard deviation, right. So, these are all the basic problems, and then one can formulate from there, right. So, this we will see, and the use cases are numerical simulations and solving engineering and scientific problems, right. So, where we are going to use this, all right. So, this we call it as mathematical computation framework. High level design, the modules are matrix operations. So, this can handle matrix computations, right, equation solver such as solving linear and quadratic equations, and then statistic module is for performing statistical calculations, right. So, these are all the modules: matrix operations, equation solver and statistics, all right. So, the key concepts we are going to use, the object oriented point of view, we are going to see inheritance, right, the classes and inheritance, right, for modularity, and we are going to also see polymorphism for extensibility, then our good old friend exception handling, right, divided by 0, right, or the negative balance. So, these are all the examples we had seen. So, we will certainly use exception handling for robust computations, and then templates for handling different numeric types, right. So, these are all some of the concepts we are going to again brush, all right. So, that already we had seen several examples of all these important concepts. So, now we will take up with some applications and then we will run the code. So, now class diagram, right. So, what we are going to have, the matrix operations. So, class diagram in the sense, so we will see we are going to use the base class for matrix computations, and then we are going to use the derived class for solving equations, right. That means I am using inheritance now, right, and the statistics will be independent class. So, here you have a inheritance and the statistics we will have a independent class. So, now the matrix operations. So, this will provide basic matrix operations like addition, subtraction, etc., multiplication, etc., and equation solver. So, this inherits additional methods for solving equations, right. So, matrix operations I put it in the base class, and the equation solver will be in the derived class, and that inherits certain additional methods, right, for solving equations. And in the independent class we have statistics. So, that is providing statistical methods as an independent class, right. So, the object oriented programming code point of view, I will start with the matrix operations class, right. So, I will discuss, then finally we are going to run the program. So, here the first application, let us say vector, right, I am including vector along with IOStream. Here you have the class matrix operations, right. I use vector of vector. What do you mean by vector of vector? So, matrix, 2-dimensional array, right. So, here the usage of vector, so double, right. So, vector, here you have the class, under vector you have vector, correct. So, anyway this is the inbuilt one, not a problem, and then you are going to have a function called add, the member function called add, public member function called add, correct. So, here we define A, matrix A, right, with the reference operator, vector of vector matrix A, vector of vector matrix B, right. So, given two matrices A and B, when I am calling add, this will give addition of two matrices, that is the meaning, right. So, this will give addition of two matrices, and similarly we have multiply, right, it is multiplication of two matrices, right. So, we are passing A and B, the reference operator A and B, vector of vector, that means the matrix A and matrix B, similar to the previous explanation, right. And here your class, this is a class, the class is over here, matrix operations, right. So, basically here we are going to have, right, this is a function, member function. So, the member function which will be adding two matrices, another member function which will be multiplying two matrices, right. So, this is the basic matrix operation class, matrix operations class. And what we have to do before going into the program, we have to validate the dimension, right. If both the dimensions are same, then you can do the addition, right. So, you have to check either complete or let us say the row, first row, right, all the columns, right, or matching with, right. Suppose A is n cross n, B is also n cross n, yes, I can do both addition and multiplication, right. If suppose B's dimension is changing m cross n, I cannot do addition, right. So, this test we have to make, right. In the programming point of view, always, right, the edge case, we call it as the edge case or the base case, we have to be, right, I mean we have to worry, right. So, suppose you have, let us say B is n cross m, A is n cross n, right, and B is n cross m, addition is not possible, whereas multiplication of A cross B is possible, A star B is possible, right, because one is n cross n, another one is n cross m. So, the resultant you will get n cross m, right. So, these are all the conditions, right. So, those who do not have the mathematics background, because it is possible that you can do. So, you have to brush your knowledge on the matrix addition, multiplication, and the base case or the edge case you have to be very careful. And the next one is equation solver class, right. So, we solve the quadratic equation or the linear equation, right, or linear system, right. So, here we are including C math along with IOStream. Name of the class is equation solver. So, here you have pair, right. The pair contains double and double, right. Even you can use a template, right. Assume that you are going to use some other, right, template we can use. We will start using it. So, pair double double, right. So, here you have two variables, right. So, double and double, and the name of the function is solve quadratic, right. Solve quadratic under the class pair, right. The inbuilt class pair, the pair contains double and double. Okay. So, solve quadratic, we are passing a, b, c, right. So, that means you have the arguments a, b, c. So, you pass as a parameter a, b, c. So, that means I am solving ax squared plus bx plus c equal to 0. So, give any ABC value, right. So, give any ABC value, I should get the output, right. So, that is one which is called as a solve quadratic member function. Another one is solving linear system, right. So, here I have capital AX is equal to small b. A is n cross n matrix, x is the vector n cross 1, obviously b will also be n cross 1, right. So, this is a linear system, AX is equal to b, right. So, I have to worry whether A inverse exists, where x is nothing but A inverse b, alright. So, here the problem is, yeah, we can solve by any numerical method, let us say Gauss elimination, solving the linear system by Gauss elimination, right. So, basically we are solving this. So, how I can write in as a function, member function. So, you have vectors of double, right, vector of double, that is a class, inbuilt class, and solve linear system is the name of the member function. Here you have vector of vector, we had seen the last program A, B, right, the matrix multiplication, matrix addition, vector of vector, double, right. So, A, this is nothing but the coefficients which are nothing but a matrix, we name it as a coefficient which is nothing but a matrix, correct, vector of vector. So, one vector size is m, another one is n, you call it as m cross n, or if you go for let us say square, right. So, you have to be careful, if we are not non-square, let us say A is n cross m, right. So, x should be m cross 1, right. So, the resultant you will get n cross 1, correct, because you have to be careful with the multiplication, that is what we have done previously, right. So, the resultant B will be n cross 1. So, that means, yeah, your n and m cannot be same, right. When you are solving system of linear equations, n and m need not be same, right. So, one is coefficients, that means A is called as the coefficients, capital A, vector of vector, size in general n cross m, and in particular always, right, we try to choose the square matrix, A is a n cross n if both n and m are equal. And then you have the vector, right, which is constant, that is nothing but your B, that is a vector. And then I am trying to find the solution for x, A and B are the input, I am trying to find out the solution for x, right. So, you can solve using Gauss elimination or several other methods, right. So, Gauss elimination, Gauss ZDL, right. So, these are all the approaches that you can use to solve LU decomposition, etc. The first one is solving quadratic equations using quadratic formula ax squared plus bx plus c. So, this is the first one, that is your first function, and this is your second, and here you have the second function, solve linear system. Okay. So, this is the equation solver class, and the third one is the statistics class, right. So, here you have vector, numeric, C math, class is statistics. So, I am going to perform, let us say, mean. So, I want to have the mean means I need a array, right, vector of data, right, vector of data, the reference operator, vector of data, the double, right. It is like this 20.3, 40.4, 80.7, right. Assume that you have 100 data like this, right. So, that is called as a vector data. So, for this I am going to compute mean, The member function is mean, and for the same data I am going to compute variance, or for different data also, right. So, here in this case data we are using, assume that this is a data, right, vector this is a vector, data is a vector, right, and for this I am going to compute variance, the member function is variance, and for this I am going to find out the standard deviation, right. So, these are all some simple statistical operations, right. So, this will perform the simple statistical computations, and also this will efficiently handle very large data sets, right. Let us say we are going to use the file contains millions of data. So, for the millions of data, is it possible to find out the mean, is it possible to find out the variance, is it possible to find out the standard deviation? The answer is yes, right. So, these are all, we will start basic program, right, and then you can work for, in fact, when you are going to the last program, we are going to have the image classification, correct. So, like this we can handle by starting the simple example. So, let us have the implementation of matrix addition, right. So, here we have taken a simple example. So, what we can do, you can extend this to, let us say, multiplication of two matrices once you know this, right, and also you can try A inverse, and also you can find the determinant of A, right. So, these are all the famous problems, right, and in fact you can develop the knowledge on algorithms, right. What is the efficient algorithm to do matrix multiplication, right, what are the ways to do A inverse. Once you know the ways, then you can also ask the question, what is the efficient algorithm to find out A inverse, right. Also try to learn how to find out the determinant of A. So, if you already know, well and good, but one more question you can ask, what is the efficient way of finding out the determinant of A? That means you are also going to get the knowledge on the algorithms, right, and computational complexity, right. Efficiency means the computation complexity. So, these things you can try, right. So, now we will take up the simple example of addition of two matrices. So, we are going to do this, right. So, here what we have to do, we have to be very careful with the size, right. So, make sure if this is m cross n, B is also m cross n, then you can do the addition, right. If it is different size, right. So, that is what we are going to discuss, right. Assume that A is n cross m and B is m cross n, you cannot do addition, right. So, this is your A and this is your B, means you can't do the addition. So, we have to have the check. So, now under matrix operations class, right, I have that add function that I already defined, right, in the class. If you recall, maybe I will just go back and show it, right. So, this you have matrix operations, right. So, under this I have addition. So, that means I have already explained A is a matrix and B is a matrix. So, now I am checking the condition, right. So, m, right, m cross n, let us say A is m cross n, B is also m cross n, right. A is also m cross n and B is also m cross n. So, A dot size is nothing but the rows, correct. So, here it is m, this is also m, then no problem, right. I can check the next condition, right. Here it is n and this is n, right. If suppose they are not, right, let us say A is, assume that m cross n, but B is m cross m, right. I will take this condition, one is true, right. A dot size not equal to B dot size, false, because both are m, right, one is false, or A0 size not equal to B0 size, n not equal to m, true. So, false or true is true, I cannot do. So, if you are given this kind of matrices, I cannot do the addition, right. You can check the various cases, right. So, here it is true, there it is false, or both are true. Both are true means I can take this example. Let us say A is m cross n, B is some m dash cross n dash, m dash n dash are not equal with m and n respectively, right. So, here also I cannot do the addition, that is what I mean, both are false, right. So, m is not equal to m dash, true, n not equal to n dash, true. So, true or true is true. So, I still cannot do the matrix addition, right. So, that is what we are going to have this, right. So, these are all the cases. So, find out another one is true or false, right. Finally, you will have true or true, right. If all these conditions are occurring, then that means the dimensions are not matching, right. If all these conditions are occurring, then the dimensions are not matching, right. So, if the dimensions are same, all right. So, let us take this case. So, then you can have the matrix addition. So, what you can do? So, here you have the result, right. So, result is a matrix, correct. So, A dot size, right. So, the size will be A dot size, and then here you have vector, right. So, comma vector of double, which has A0 of size. So, all the elements you are making it 0, all you are initializing to 0, right. The result matrix will be like this, that is what that line is telling. Assume there is a 2 cross 3 matrix, both are 2 cross 3, A is also 2 cross 3, initially you are making like this, correct. And then you have one for loop, that for loop is running for the rows, A dot size, as I already said, rows, right, and A0 dot size column. So, for I is equal to 0, I less than rows, j equal to 0, j less than columns, you are adding the component wise addition, right, and then you are putting in the result of I comma j, right, the result matrix I comma j, you are adding two matrices, right, A and B is given, right, A and B are given, and then you are adding, put in result ij and return result, right. So, this is what exactly will happen, because the resultant is a vector of vector matrix, right. So, this is about your matrix addition. And similarly, we have quadratic equation solver, right. So, solve quadratic. So, this equation solver is the class already we have, and pair double and double. So, you are passing ABC are doubles. Now, discriminant you are calculating b squared minus 4ac. So, you are given ax squared plus bx plus c is equal to 0. This I am going to solve, right. A, B, C you are passing. If the determinant less than 0, right, if determinant is less than 0, throw runtime error. So, it is throwing the exception and no real roots will be printed. Yes, if b squared minus 4ac less than 0, then you can't find any real root, right. Otherwise, root 1 is minus b plus the square root of discriminant plus or minus root of b squared minus 4ac by 2a. So, this you are writing as a code, right, minus b plus or minus b squared. So, I will write b plus or minus root of b squared minus 4ac by 2a root 2. So, return root 1 and root 2. So, pair, right, that you are returning, right. So, this is quadratic equation solver. So, here we have the mean member function, right. So, we are passing vectors of data, right. So, it will be like 20.3, 80.4, I said already, right, like this 100.2, right, whatever be the size, right. So, begin, and I hope this is the last element, let us say 104.7, right. So, this is data dot begin and this is data dot end, right. Your sum is initialized to 0, that is the meaning over here, right. And then whatever be the data, so initially 0.0 will be added with 20.0, right. So, we will have the sum and then sum will be divided by size of the data. So, we know it is a mean, right. So, that will be returned, okay. So, that will be returned, correct. So, this is the mean calculation with the help of the member function, right. So, here we are using the standard accumulate inbuilt, right. So, you can write your own code, which is not very difficult, okay. So, this is how we do the mean calculation, and also we are going to have the error handling exception, right. Suppose you are having the invalid matrix dimension, or in a system of equations, right, you have the singular matrix, assume that you are having a singular matrix, right, and the negative discriminant in the quadratic equation. So, for example, I have the equation x squared plus x plus 4 equal to 0, right. What is minus b plus or minus b squared minus 4ac? Negative, right, 4ac, 2a, 2 into 1, right. So, 1 minus 16 square root minus 15, right. So, we cannot get the real root. So, in that case what will happen? So, it is trying to throw, right, when you are it is trying. So, if it is a negative root, it will throw some exception, right. So, that exception will be caught over here, error, right, and then we are going to say something, right. So, in fact, we have written, if you recall, we have written, right. So, throw runtime error, no real roots, line number 4, right. So, that will happen, all right. So, that we are going to have, right. So, this is one of the examples where we can have the error handling exception as well, right. So, with this in mind, So, let us have this particular program, the complete case study, right. So, here you have void save results, a function, right. So, which has results of vector, right, and matrix result vector of vector, that means this is a matrix. So, the first one is a one dimensional array, second one is a matrix result is a matrix, and here you have a file name, right, the string address file name, right. So, you use OF stream, recall whatever we have studied that we are going to use OF stream, we have already done file of file name, right. If not file, that means file, if it is if file, file not equal to 0, file not equal to null. So, if it is null, right, if the file does not exist, unable to open, right, if the file does not exist, unable to open will be displayed, right. Otherwise, here you have file, right. So, this will be returned, right, this will be writing in the file, right, whatever you are writing in the code, number, results, quadratic equations, roots, right, and then root 1, whatever you are going to calculate, results 0, right, it is a vector, results of 0, right, and then results of 1. So, these things will be returned in the file, and file mean calculation will be returned, mean, results of 2, right. So, here you have a root 1 and root 2, result 0, result 1, and mean calculation I will use another result, results 2, right. In fact, it is a one dimensional array, vector, right. So, result 0, result 1 I will use for root 1 and root 2, and result 2 I will use for mean calculation. Then here you have the matrix addition file, matrix addition result, right. So, here I have the range for loop, right, matrix result copied into row, right, which is auto variable, and a row will be copied into val. So, that means you have two for loops, one is running for the row, another one is for column, right, and then you are, right, whatever you are getting the output as addition, right. So, you are writing in the file value, right. So, then file new line and file close. So, here we have handled the file handling system we have studied, right. So, now we will go to the computations, the mathematical computations. So, now I am going into the main, right. So, here you have the function, save results function, right. So, that means you are going to handle the file, and then in the case of a main function, I have under matrix operations class, I have matrix OPS object, under equation solver I have solver object, right. Under statistics class I have stats object, right. I have vector results, right, one dimensional array. Here I have a matrix result, two dimensional array. So, now I am passing 1 minus 3 2, that means I am trying to solve 1 x squared minus 3 x plus 2 equal to 0, right. So, we have already seen, right, the solving equation, right, all the programs we have already seen, right. So, this will be called. So, in fact, we have defined previously, right, all these functions we have defined previously, solve quadratic, right. So, here you go, solve quadratic, right. So, these are all I explained. Maybe when we are seeing it as a program, we are going to see this, all right, solve quadratic, you are passing 1 minus 3 2. So, this function will be called, this function we have member function I have already defined. So, auto roots, so whatever you are getting as output, all right. So, double, all right, that you are going to get. So, now see out roots, you are writing roots first and roots second, right. So, then you are having the push back, push underscore back, this we had seen several times. So, the first root will be returned, right, and then let us say first root, whatever the root, let us say root R1, R1 is some number, right, and then push back second R2 in the list, right. So, this you are writing the root 1 and root 2, right, and then mean calculation you are trying, you use the try throw catch, right. So, load data, data.txt will be loaded, right, the some file will be loaded, and from that file you are reading, storing as a data, which is auto variable, and you are calculating the mean, we already written the function mean, right. So, start data, end data, and then, right, divided by data size, you are calculating the mean. So, which you are doing over here, see out mean, right. So, push back mean value. So, here you can call another, right, mean, right. So, if there is any problem of handling the data, right, so it will throw the exception. So, error loading the data and e dot what, right. So, whatever you have written, so you cannot handle the file, right, unable to open the file for writing, right. So, something like that will be printed, all right. So, if this is happening, so push back 0. Third one is matrix addition. So, you are taking one matrix from the text, right, A, another matrix from another text B, txt file, right, and then you are calling the add function. We have already seen matrix A, matrix B you are passing, we are calling this, right. So, whatever you are reading, storing in matrix A, whatever you are reading, storing in matrix B. So, use again try throw catch, right. So, you are passing matrix A and matrix B, we have already done this function. So, matrix result will be computed, right. So, matrix addition result. So, to range for loop, matrix row and column, and then you are printing that value, right. So, this you are doing, printing the matrix, right. So, in case any problem reading the file, it will throw the exception, right. So, exception will be caught here, right. So, now you are doing the save results, you are calling save results. So, save results, you are passing results, matrix result, right, and results.txt, right. So, it will store it in results.txt file. We will see all the files, whatever file we are using, right. So, one file we are using data.txt, another file you are using matrix A.txt, third matrix B.txt, and the result you are going to write results.txt, right. So, here you have results, right. You are passing results, matrix result, and the file that it is going to write, and then it will save it in results save to result.txt, right. So, when I run the code, I have to get the output. So, before that we will see what are all the files. We will go and see the files. So, data.txt. So, this is the data, right, 1 2 3 4 5 6, all right. So, you have, we can write whatever we want, and matrix A, all right, and matrix B, and then results.txt should be empty, all right. So, what we will do, we will cut it and save, right. Now, initially empty, maybe one more time we close it and I will open again, right. So, you can find it's empty. So, now we will run the code. Yeah. So, when we run the code that I have explained, right. Yes. So, you can have some mean, and then it is showing certain errors. The reason is your we will see matrix A 2 cross 4 and here 2 cross 3. Yes, I should get the error, right. So, now, yeah, so I should get the error. So, now what I will do, I will delete that one also. So, now both are 2 cross 3, correct. So, now when I again run the code, I should get the output for matrix. Let us see. Yeah. So, when I look the results, yeah. So, now matrix addition result is we are getting, right. And if you look at data.txt, I will explain one by one. So, when you open data.txt, so here you have 1 2 3 4 5, and purposefully I put one blank space, then 4 5 5, right. So, the result should be addition of all these divided by 8, all right. So, you can make the computation, you can just check also, and if you look at the output, we are getting, here you go, 3.625, all right. And the second one is, if you look at the code, all right. So, we will go to the code, and here you have, we are solving the quadratic equation for x squared plus x plus 4 equal to 0, right, x squared plus x plus 4 equal to 0. So, the discriminant will be obviously less than 0, right. So, in that case, if it is a negative, so it has to throw the exception. So, the exception is here, no real roots, error colon no real roots, and then we will open matrix A.txt. Already we had, I have told you, but still matrix A is 2 by 3, matrix B is also 2 by 3, right. You add both, right, you will get the result. So, result is here, right, the addition of two matrices. So, now also we are getting one more information, results saved to results.txt, right. So, if you look at results.txt, initially it was empty, if you recall, yes, now you can see no real roots, mean, matrix addition result, okay. So, these are all the results we are getting, okay. So, this is what the output is, right. This is some other, okay, equivalent to this we are getting, right. So, here we have kept on changing few things, right. So, we have to get the output like this. In fact, one more time we can see the output file. Can you go back to that? Yes, if you, the result results.txt, right, you can see that if there are any roots, right, if a discriminant is greater than 0, we will get the output, and then mean is printing, matrix addition result is printing. So, here I am printing the equivalent one, assume that you are having the roots, right. So, the equivalent one will be printed. right. So, these kind of problems you can test, right. So, here we have handled so many, right. So, we have used the error handling exception. Here you have a class, all right. So, various classes we have used, right. So, mainly we have used the file handling system, right. So, like this we are going to see some more programs also in the next few classes, right. So, that means whatever the object oriented programming concepts that we have seen some of them, right, and then we have got the results, right. So, one has to be very careful with the test cases, right. So, suppose you are using singular matrices. So, let us say solving for Ax is equal to b kind of problem, or in the addition or multiplication, right. Suppose you are taking the right the dimensions, right, the different dimensions, right. So, one has to be very careful for these edge cases, you call it as the edge cases, right. So, suppose the negative discriminant happens, in fact one of the examples we had seen how to manage that, or even the large data sets, how to handle large data sets, correct. And suppose you have the input, right, the wrong or invalid input file, right, or malformed input file. So, in that cases how do you use, right. So, all the cases, most of the cases we use the try throw catch, right, the error handling exception. So, you one has to be very careful and try to use the exceptions, right. So, we have used the class, file, right, and error handling exceptions in the previous case study, all right. So, the main challenges that you may face, right, handling the large matrices, suppose 3000 by 3000 matrix, you have to do the multiplication, all right. So, now you have to think about the optimized code, either you can do or take out the library, right. For example, eigenvalue computation, eigenvector computation, right. So, one has to be very careful how to handle the large matrices, right. So, the error propagation. So, when there are errors, I mean you carefully handle with error handling exception and extensibility, right. So, I mean we will talk about this, right. So, suppose I am going to use that inheritance concept, right. So, we have to design the modular classes to support future enhancements, right. So, these are all the challenges, and in fact we have the solutions as well. So, this is a summary of the framework. So, we built a modular framework for advanced computations, particularly the mathematical computations. So, we have implemented addition. So, what you can do, you can try multiplication, finding out the inverse, finding out the eigenvalue, determinant, right. You can extend. We have seen quadratic equation, you try to solve the linear equation, and in fact you take the matrix which is singular, right, Ax is equal to b, A singular, and see how you can use error handling exception for those. We have solved for quadratic. We have seen mean, you try to compute variance, all right. So, and moreover with the help of file handling or exception handling, so you can solve these kind of problems. So, with this I am concluding this particular case study. Thank you very much.